What's happening, dogs? Mr. Allen here with some graphing of cubic polynomials in this video, and these happen to already be in factored form, which is great because that makes it super easy to get our x-intercepts. So let's try this first one here. I've got f of x equals the quantity x minus 4 times the quantity x plus 2 squared. So there is something special here about a factor being squared graphically. Rather than passing through our x-axis, it is going to bounce off underneath or above. It's going to be tangent to that x-axis. So first, let's get our x-intercepts and our y-intercepts as the directions say here. So my x-intercepts, let's see here. If I set this equal to 0, I'd get 4, 0. Right? 4 minus 4 would give me 0. And if you need to, you can always do a little side math and be like, okay, x minus 4 equals 0, add 4, and I get x equals positive 4. Always helpful to do a little side math, especially if there's like a coefficient or something like that in there, and it's more than one single step. Now for this one, if I did a little side math, x plus 2 equals 0, I'd get x equals, we'll subtract 2, I get negative 2. So my other x-intercept is negative 2, 0, and that's going to have a multiplicity of 2 because of the squared binomial right there. So oftentimes I'll just say multiplicity of 2. They might ask, like in a multiple choice question, which of the following functions have factors with them, or sorry, x-intercepts with a multiplicity of 2? This would be one of them. G of x, also one of them. Not that I want to look ahead. We're having too much fun with this one already. All right, how about our y-intercept, right? There's only one y-intercept if a function has a y-intercept, and all polynomials will have a y-intercept because the domain is all real numbers. So for this one here, my y-intercept, how would I get that? Well, my y-intercept for any function would have the x value being 0. So what if I were to just plug in 0 for x and evaluate it? It's not a bad idea, right? So if I do that, I'm going to do a little more side math here. If I plugged in 0 for that factor, let's see, we have f of 0 equals, well, that's just going to be negative 4. And over here is going to be positive 2 squared. So that's going to give me, let's see, negative 4 times 4 is negative 16. So it's 0, negative 16. If you got to do a little more and do 2 squared is 4, and then negative 4 times 4, that's fine. I'm trying to save a little bit of space there. But my y-intercept is 0, negative 16. And I left the y-axis here unscaled in both because sometimes that y-intercept can get a little out of hand and we just don't have the tick mark. So usually we will leave it unscaled for you and we would just plot that point 0. I'll do it right here. 0, negative 16, and I'm going to label it 0, negative 16. Okay, cool. Now let's plot our x-intercepts, right? We got 4, 0, 1, 2, 3, 4, and I have negative 2, 0. And this is the one that is a multiplicity of 2. So it is going to bounce off of that one. Now, what I like to do when I'm graphing cubic, quartic, quintic, whatever it may be, I do a rough sketch off to the side and think of like a plan of attack of how this is going to look. So this is a positive cubic function. There's no negative value out front. Both of my x's in here are positive, and it's 1, 2, 3, because it's squared here, a degree of 3, right? You can get into quartic polynomials. It's a degree of 4. Quintic polynomials, a degree of 5. Whatever. We're dealing with cubic in this video. So this guy's going to look something like this. It's positive. Okay? Now, it's bouncing off of the first one here, right, at negative 2, 0. So it's got to bounce there. Well, the only spots it can bounce are at a local max and a local minimum, right? There's no absolute max or min in a cubic function because it's going to go up and down forever on one side of that function, right? So there's no absolute max or min. It's just if I look at that little part, local min, right? Look at just this little part, sorry, local max. Look at just this little part, local min. Well, which one's it going to bounce off of? If you answered the local max, you are absolutely correct. Well done. Well done. So my x-axis is going to be right here. Okay, so that gives me a general idea of how this is going to look, right? It's going to be like, whoop. But am I going to go past my y-intercept and back up, or should I dip below my y-intercept and come back up? Well, you can see it looks kind of awkward if I go below it and then come back up. That's not what we want it to look like there. So really, I want my y-axis to be somewhere around here. I'll go below my y-intercept and then come back up and through that x-intercept. So let's go ahead and do that now that I have a general plan of attack. All right, I'm going to go from down here. Then I'm going to pass through my y-intercept and come back up. Boom. Sometimes it's good to like wait to label your y-intercept so it doesn't interfere with your graph, but you don't want to forget to label your y-intercept. So I just label it, pass right through it. If I were the one grading your test, I would not count you off for, your graph passing through it. Good to label that y-intercept so you do not forget, okay? So there we go, guys. We've got our multiplicity of 2, regular old x-intercept that it passes through, got my y-intercept, and you notice that, yeah, coming through it and coming back up allows you to be a little more consistent with that curvature of the function. If I went below first, I'd be like, whoa, I got to come way over, okay? So plan of attack first to help you get a nice cubic function. That's going to help, okay? Because otherwise, these graphs tend to look absolutely terrible. A couple other things to point out would be arrows pointing, right? We got to have arrows on the end of our graph. Make sure that your graph does not flare out, okay? It should not be flaring out. Also, make sure that it always passes your vertical line test so that it is a function. If you go, like, if I went to come down, I'm like, whoa, I went past, and I come back, right? We don't want that because then now this section here, it does not pass the vertical line test. It's no longer a function, taking a half point off, maybe even a full. No, I would take a half point off, okay? If you come out and back and it doesn't pass the vertical line test, boom, half point off, VLT, baby. All right, cool, awesome. Any questions? No questions. Let's do this one over here now, which is an interesting one because I've got a -5 out front. This one didn't have a lead coefficient like that. It's just 1. Then I got x squared by itself. Weird, nothing's added there. And then I have x minus 3. Well, let's get our x-intercepts and our y-intercept to start. So x-intercepts. That one I know is 3, 0, right? That's cool. 3, 0. If I set it equal to 0 and solve like I did over here, I'd get 3. What about x squared? What makes that 0? Is the -5 involved at all? No. So if I were to set it equal to 0, and I'll do like a little side math. That was a voice crack, but I'm leaving it. I don't care. If I just set -5 x squared equal to 0, I would divide by -5. So really, the -5 there plays 0 role in the zeros. That is a lead coefficient that'll stretch our graph vertically. The negative's going to flip it. All those good things. But it doesn't play any role in our actual zeros because I still have x squared equals 0. So I guess I square root, right? Well, what's the square root of 0? It's just 0. So if I just have an x, or an x squared, or an x cubed, right, or a 10x, or a 7x, or a -2x, or a 13x, or a -100,050,000 2x, it's not even a number. In any event, it's x equals 0 is going to make that 0. So I end up getting 0, 0, which would also mean that my y-intercept, if I'm going through the origin, 0, 0 is also my y-intercept, okay? So anytime you have 0, 0 for an x-intercept, it ends up also being your y-intercept because it's passing through both the x and y axis at that time. The other one's 3, 0, lovely. And which one am I bouncing off of? I'd be bouncing, here, let's see, multiplicity 2 for that one. I'd be bouncing off of my origin, right? So let's get a little practice graph here. Like I said before, let's get a little practice. This one's negative. So instead of looking like this, it's going to be flipped. And now I'm thinking here, I'll do it right here. Now I'm looking something like this. That's my general sketch of things. It's going down and to the right instead of going up and to the right. And it's got to bounce off of the 0, 0, right? Because that's the multiplicity of 2. So which one's it going to bounce off of? My local minimum or my local maximum? It's got to bounce on the first spot. The only places it can bounce are those local mins and maxes. If it's bouncing off the first one, it's got to bounce off the first one. That makes sense. So here's my x-axis. What about my y-intercept? Well, it's at the same spot, isn't it? So there's my y-intercept, my y-axis, excuse me, and we're ready to rock and roll, man. It's no big deal. No big deal. Boom. So I'm going to come down. Whoop. Beautiful. Now, some teachers might ask you to find like an additional point. I don't always require that. I just want to make sure that it is going down and to the right. Once we get in a little more advanced or a little more graphing, perhaps I would ask for another point. And we could do that. We could plug something in. Let's try it, all right? Just in case your teacher asks you for an additional point, let's find another one. Well, how do I find another point? If I have an x value, I can just plug it in, get my y value. Let's do like 1. That's an easy number to work with, right? Let's do g of 1. That's going to be -5, 1 squared times 1 minus 3. Hopefully we can still see that. Hey, it fits, right? I got a little screen on my watch. I got negative 5 times 1 times negative 2. That is 10. That looks right. Cool. So we plugged in 1. We'll just put that order pair there. 1 comma 10 is an additional point on our graph. Right? The y-axis is not labeled, so I had to label it. 110. This is labeled, but the y value is not. Okay? So there we go, guys. 2 of them beautifully graphed, right? We got arrows going up. It passes the vertical line test. It's not like, woo! It's not flaring way out, right? So these are both ideal graphs here. That would get you full credit. I mean, I'd give myself full credit, 100% right here. All right, you guys. Thanks for watching. Gonna do a couple other ones like this as well. Definitely some with like multiplicity of 2, helpful. Sometimes we don't have that, and it just passes through all of them. There's also a multiplicity of 3. That'd be interesting to see. Perhaps I'll do that in another one. All right. Thanks for watching, you guys. Have a wonderful day.